Welcome to In 5 Minutes. In this video clip, we'll discuss various types of amplitude modulation. There are different types of AM signals that we can transmit from the transmitter side. The very first type of AM is DSB-FC, something that we discussed, something that we use to understand any conventional AM system. So double sideband full carrier is also called conventional AM signal. Double sideband full carrier simply means that the signal that we are transmitting has two sidebands. That's why double sideband DSB. Now these two sidebands are nothing but upper sideband and lower sideband that we already discussed. And apart from that, FC means full carrier. That means apart from transmitting two sidebands, we are also transmitting entire carrier signal from the transmitter side. So entire carrier is what we are transmitting, and that's why the name full carrier. And because we are transmitting two sidebands, it is double sideband DSB. So now when you transmit double sideband full carrier, the total bandwidth of the signal required will be twice FM, because every sideband has the bandwidth of FM. And if you remember, the frequency spectrum in that case will look something like this. Let's say you have a carrier frequency here. This is the lower sideband which goes up to FC minus FM, and on this side, let's say you have the upper sideband which goes up to FC plus FM. So this is the spectrum on one side, and similar spectrum you will have on the other side also, which will be present around minus FC. So you can see the total bandwidth between the two frequencies, extreme frequencies, will be nothing but twice FM. Now there are few drawbacks of double sideband full carrier, and because of this we go to the other types of AM signal. The very first drawback is that the amplitudes of carrier signal and the other signals, that means the two sideband frequencies that we have in the signal, because it is the full carrier version, the carrier part in the output signal is exactly same as the original carrier signal. So let's say the carrier that we have is present in the output signal with amplitude Vc. Now if you remember, both the sidebands, upper sideband and the lower sideband, each will have the peak amplitude of m Vc by 2 in that case, where m is the modulation index and it should be less than 1 to avoid over modulation. Now because m is less than 1, it turns out that m Vc by 2 is also less than Vc. We will discuss in one of the video clips the amount of power which the carrier has and the upper sideband and the lower sideband have. Because Vc is greater than mVc by 2, if we find out power of the carrier and power of the sidebands, it will be very obvious that power in carrier is much greater than the power in the sidebands. Now what is the problem due to that? The problem is that the carrier is just used to translate that low frequency range to high frequency range. The carrier as a single frequency does not have any information. The actual information is present in the upper sideband and in the lower sideband in the form of FC plus FM and FC minus FM. And because the information is carried in the sidebands and information is not present in carrier frequency FC, the power which the carrier contains is of no use to us, because that power does not carry any information. The actual information will be carried by the power which is represented by the upper sideband and the lower sideband. And just because of that, to save lot of power which does not contain any information, we may suppress the carrier. That means it is preferable to transmit only the two sidebands and not transmit the full carrier. Does that mean we are saying that the carrier is not required anymore? The carrier is definitely required in the process of modulation to carry out this up conversion. But once the sidebands in the form of FC minus FM and FC plus FM are generated, after that there is no need of carrier to remain in the output signal. There is this another type of AM which is called double sideband suppressed carrier. So here we transmit two sidebands. Two sidebands will be upper sideband and lower sideband, but we transmit no carrier. I repeat, SC is called suppressed carrier. So what is the advantage we get? Advantage that we get is out of the total power which is available, all the power will now be distributed in the upper sideband and the lower sideband, which are the bands that are actually carrying the information, and no power will be taken up by the carrier. That is because the carrier is absent or the carrier is suppressed from the output side. And hence, the power efficiency of the double sideband suppressed carrier process will be much greater than the power efficiency of the double sideband full carrier. Is there any advantage in terms of bandwidth? No, the bandwidth required is still 2 FM because we are transmitting both the sidebands. So the bandwidth is still equal to 2 FM. What is the advantage we have achieved? The advantage that the power efficiency, which is one very important factor in any process, will be much higher for double sideband suppressed carrier. In simple words, the wastage of power is reduced greatly in DSB-SC.